So the Te Mihi geothermal plant in New Zealand was commissioned in 2014, and it is a geothermal plant that generates electricity using the Earth's natural resources due to the location in the Taupo volcanic valley. And they use electrical generators. Now, generators are devices that convert mechanical energy into electrical energy. In this case, the mechanical energy has already been generated by a steam turbine. So what the electrical generator does is converts that so that the electricity can be stepped up to the national grid. Now, the opposite conversion, going from electrical to mechanical, is done by an electric motor like you would have in a vehicle. Most of generators are going to be alternating current, known as AC, or alternators, and a fewer amount of them are DC generators, and they're known as dynamos. Now, today, generators typically produce electricity at about 93.5% efficiency. What gets lost is in the windage, the bearing friction, and of course in heat, which you always have a problem with. Now, much like a steam turbine, a electrical generator also has a rotor and it also has a stator. Now, the stator is everything that does not rotate in an electrical generator, all the non-rotating parts. It has these large coils of wire that create voltage and current in the presence of a magnetic field. It can have anywhere between 2 to 4 magnetic poles usually, and it depends on the speed of the rotor's rotation. Now, the rotor part, probably obviously, has all the rotating electrical parts, and it has coils of wire where a magnetic field is created using DC current, because DC supplies an electrical generator and it converts into AC current from mechanical. And the rotor is connected to a spinning turbine. Now, one of the really interesting things that geothermal plants do is they use what's called a resistivity boundary. Now, resistivity is a measure of the resisting power of a specified material to the flow of an electric current. And so, underground geothermal fluid, the water and steam mixture, has a low resistivity due to all the dissolved salts and compounds that are in it. So it conducts electricity well. So the resistivity boundary is when this resistivity increases, and scientists can use this to indicate the outer boundary of hot water in a geothermal field, because once you reach that boundary, it's not going to conduct electricity as well. A few important things to keep in mind when you're looking at electricity generation and generators are Faraday's law and Lenz's law. Obviously, they're two of some of the most important laws governing electromagnetism. Now, if you remember, Faraday's law of induction states that the induced EMF in a coil is proportional to the negative of the rate of change of magnetic flux. And keep in mind, magnetic flux is the flow of energy. Now, Lenz's law states that the induced current produces magnetic fields, which tend to oppose the change in magnetic flux that induce such currents. So when we talk about magnetic fields and how they relate to electricity generation, that's where that relationship is coming from. One of the things that's really important in a power plant is keeping constant frequency. Now, alternating current, or AC, means that the electron's direction is continually changing and can be graphed as a sine wave, so up, down, and it has an amplitude, frequency, etc. The frequency is defined as the number of occurrences per second, and of course it's measured in hertz. Now, New Zealand's national frequency is 50 hertz, while the United States is 60 hertz. So that is one of the reasons when you go overseas from America to New Zealand, you have to have a converter or an adapter for your electronic equipment. Now, it's important for New Zealand's national grid to maintain a frequency between 49.8 and 50.2 hertz. So it has to be pretty close within that 50 for it to be constant. The frequency of an AC generator in hertz is related to the number of poles, like we previously discussed, and the speed of rotation. And that's given by frequency equaling the number of poles times the speed of rotation divided by 120. And so the speed of rotation is going to be revolutions per minute, pretty commonly known as RPM. The 120 is just a constant to allow for the conversion of minutes to seconds and from poles to pairs of poles, because that's how the equation works. And so obviously the generators have to be kept at a constant RPM to ensure a constant frequency, and that's how that works. New Zealand's national grid is about 12,175 kilometers long network of wires that's used to distribute electricity throughout New Zealand. Some of the specifics about Te Mihi are its total electricity generating capacity is 166 megawatts, which is a much higher generating capacity than Wairaki, which was the original geothermal power plant in New Zealand. It was commissioned in 1958. Te Mihi was the upgraded station to eventually replace Wairaki. So some of the information about the generators that Te Mihi uses is they are made by Toshiba. The kilovolt amperes figure is 108,706, so 108,706. Now, kilovolt amperes are calculated with both voltage and amperage in the RMS values, the root mean square, and volt amperes is used when specifying equipment loads, fusing, and wiring sizes. So you'll see that common in the industry. Another thing that you'll see looking at these generators is it'll talk about phase, such as three-phase, and three-phase circuits are ideal for allowing high power transmission for the same electric current. It requires less copper, and they're generally safer because they transmit lower voltages. And three-phase current is the most common way of generating and distributing AC electricity. Now, these generators, as previously stated, they can have between 2 and 4 poles. These here at Te Mihi have 2. Again, they run at 50 hertz. The volts for each one is 11,800. Amperes for the current, 5,319. And an interesting thing about them is the insulation class. And the insulation class for these generators, class F, is the most common for international and 50 hertz equipment. Its maximum operation temperature allowed is 155 degrees Celsius, which is 311 degrees Fahrenheit. One of the interesting things that you'll see in this photo, if you look closely, is a change in the size of stone, and that is used as a warning due to the electrical hazard. And here at Te Mihi, according to their engineering manager, the mechanical engineers actually aren't even allowed anywhere near the electrical equipment. So they have very specific job duties due to the dangers involved.